Hello everyone, my name is Rakesh Rangu, Assistant Professor in Mathematics, Department of FME, Saint Martin Engineering College. Today I am going to be here discuss in online lecture video. My topic is that normal distribution, which have the more applications in statistics. So let's see that what is mean by normal distribution with the definition. So it is then defined as continuous frequency distribution of infinite range, and the mathematical formula for here we have f of x is equals to 1 by sigma under root of 2 pi into e to the power of minus 1 by 2 into x minus mu by sigma whole square. Here, so the values of x mu sigma are defined like so here the values of x is going to be minus infinity to plus infinity, as well as mu also going to be from minus infinity to plus infinity, and the value of sigma is going to be greater than or equals to 0. And here we know that mu and sigma are going to be both are parameters of that normal distribution. Why? Because based on that mu and sigma only we can define that what is actually normal curve. So let's see the next slide for us. So here mu is called that location parameter and sigma is called that standard deviation is called spread parameter. How it is that? Because here the value of mu based on that the given normal curve is going to be placed. So this is a bell-shaped curve, and if that mu value going to be 0, so we get a normal curve is going to be like, if that mu value is going to be negative value, means that less than 0, so that normal curve is going to be lies on the left hand side. That mu value is going to be greater than 0, the normal curve is going to be lies on a positive, means I think in a right hand side. This by this hence we can say that mu is called that location parameter, since based on that mu values only the curve going to be placed on left hand side or right hand side or middle of the curve. Next sigma, the standard deviation is called that spread parameter. Why? Because here based on that sigma value, if the sigma value is going to be more lesser, sigma value is going to be less value, is it here, then the graph is going to be for us like, means it's going to be more big. In case if that sigma value is going to be more larger, so we may expect a flat line. So because of this one only, we call this one sigma as that spread parameter. For this, I would like to give an example by using that video. So let's go for this one. So this is going to be a bell-shaped curve that we are going to be seeing the normal curve. So here I would like to consider that average height of that human being. So some of that height going to be short. So if you consider the population of that any country, some of the people, means few people only are going to be very short and few people are going to be tall, but the average height of going to be huge people are going to be possible for us. And here but the y-axis is going to be show that what is the height, I mean how many people are there. So rarely we can say that the people are going to be very less height, means a less amount of people going to be low. That's why, and the curve going to be low, and here also the tall persons are going to be some of the members only possible. That's why here. But coming to that average of the height is going to be huge number of people we can see. So we can go for here. It is distributed like. Now I would like to go for that I like to compare that to two normal distributions for that newly born baby as well as the adults. So here that height of that newly born baby going to be approximately average of height of the newborn baby is going to be 20. The average height of that adult is going to be 70 inches. So normal distribution always centered on that average value only. Let's go for this one. So it may be oscillated from that 19 or 20, 21. In between that the newborn baby height in inches. Coming to that adults, that the average height going to be 60 to 80 inches. So you may observe here there is a clarity for us. Okay, by comparing these two, we can give it. There is many options for us at here, and coming to be here, we have only option that is. So here. Now let's go for see this one, and the distance from here to is known as the width of that curve is defined as the standard deviation, and okay. By comparing these two standard deviations of this one, that the newborn baby standard deviation going to be 0.6, the standard deviation of adults going to be 4. So knowing the standard deviation help, because we are going to be considering that 95% of measurements that going to be average height going to be 20, either going to be plus or 2 is going to be possible. Coming to that adult stage, the average height going to be 60 to 80, but it may be going to be lies like between that 90 to 650 is going to be possible for us. These are the so that's why we can define that. Previously I told you that is called that spread parameter of the standard deviation. So if you want to draw the normal distribution, normal curve, we need to know two things. One is going to be average measurement, which tells that center of the curve goes, and the standard deviation of the measurement, it helps to know the width of that. Based on the width, we can define that standard deviation of it. Next, we have so we have more applications are here. So we can go for that average height, average weight, common, etc., etc. Like we may go for that finding that marks of average of the students. Everything we can discuss. In statistical, we have more applications are there in by using that normal curve. Let's go for one more thing that importance. Majorly. We have a lot of applications in statisticals only to find that value of it. And let's go for that normal curve characteristics. It always going to be a bell-shaped one only. First characteristics. Next going to be here. The curve is always going to be symmetric about x is equals to mu is equal to 0 line, and is always symmetric in the sense the total probability under the curve above x-axis is going to be 100. It divided into two parts, 50%, 50%. And in normal curve, the mean, median, mode of that random variable is always going to be equal. Next go for that, so look at here the average, the total area under that curve above the x-axis is either we may consider value of 1, or it is going to be shown as that 100 degrees, 100%. Now this is an example for that IQ score distribution. The y-axis represents that percentage of a population, and we know well that gifted children having that more than 160 IQ. And so remaining by based on the statistical data, so we can classify or we can form that a normal curve. Like look at here, the average IQ of that population is going to be how much? 85 to 115. That's why it is going to be 2 peak. Okay, now and median also is there, width also is there. Next coming to the next color is going to be next level of IQ person. Next we spread line. Next go for the next slide. Okay, it is divided into totally like 50. Okay, now in the same here we can write one thing at here. If it's going to be x is equals to mu, so we can write this one going to be x is equals to mu minus sigma. Next, x is equals to mu minus mu plus sigma. Next is equals to x is equals to, okay, mu minus 2 sigma, x is equals to mu plus 2 sigma. And always remember that the normal curve never going to be touch that x-axis. So overallly the 99% of that the value whatever we require probability, okay, is going to be in between from where mu minus 3 sigma to mu plus 3 sigma. Only in this range only 99.7% going to be concluded. Okay now, so next go for next slide. Now coming to that, how can we determine that values of that the probability by using that normal curve? For that we need to convert that given values into standard normal distribution. So when it is known as the z square also, so it is defined by the mean value is going to be, sorry, here the value is going to be greater than or equals to 0 and the standard deviation value going to be sigma. If that given normal distribution curve having this mean values like mu value going to be, mean of that normal is going to be greater than or equal to 0 and strictly standard deviation should be going to be 1, then the given distribution is called that standard normal distribution. So let's go for the, by using this formula. Okay, if x scale is given for us, we have to convert into z scale. This is called that z square also. Okay, let's go for some examples on this one. Okay, the total area we have already discussed this one, and okay, I would like to represent it here. The total area under the curve is entirely going to be 1. The area in red is equals to that p is equal to z. If we are this is the area going to be known as the probability of p value is going to be greater than 1. Next, the left hand what you given in that blue color, that's going to be probability of okay, -1 less than z. Like we have to represent. Then how can we find exact probability value for a given question? Let's see with some examples. This is the conditions we have how to find that values exactly, probability values are going to be area under the curve. So how to find that p of x1 okay less than x less than x2 is equals to p of z means suppose x1 is given any value for us, x1 is given any value for us, we need to find it okay now z square, that is going to be as general as z1. Next, x2 going to be any given value for us. By converting into z square, we get a value that is going to be z2. Now I need to find the value of probability in between z1. Sorry, it's going to be z less than z2. So by taking the graph, is going to be considered as x-axis, and the value of z going to be at here 0. The right hand values we have to consider as 1, 2, 3 up to plus infinity, and left hand side going to be -1, -2, -3 and minus infinity. So now I want to know that I like to write first a bell-shaped curve. So z is equals to be 0 at here. Next, first I need to evaluate if both are going to be positive. One, if both are means z1 z2, by evaluating the value we get both are positive values, is going to be like z is equals to, suppose it here z1 one value, next here z is equals to z2 one more, both are positive. I need that between area, that is our required probability value. So for that so I would like to okay draw from here. This is going to be total area we can find. This is noted as that area of z1, which I shaded horizontal line, area of z2. Next, so which I am using that vertical lines. This is represent that area of z1. So as we know basic concept, if you want to know that area of z okay less than z2 is given by, from here to here is going to be area of z2 minus from here it is going to be okay area of Z1. So this value gives for us what is the area, or it may be noted as that probability in between x1 and x2 whenever both are going to be positive. Let's go for next. Next, I want to verify the second case that if both are going to be negative, means Z1, Z2 values are going to be negative are there, then how can we get that value of it? Let's check out once. Okay, first draw that normal curve. Normal curve right here. The value of Z going to be 0. Attention, we know that positive values. Next to go for left hand side going to be negative values. And both are going to be negative in the sense this is going to be, let us that Z1 at here, this represent what? Z2. I want to know that area between this area I required. So for that we need to subtract that area of Z1 from area of Z2. This is going to be required for us. The probability of Z1 is less than Z is less than Z2. So this is going to be required for us. And how can we evaluate the value? Also, I'll explain with an example. Next, last one is going to be case 3. If both are going to be different, and means one is going to be positive, one is going to be negative. How can we find it? Let's see this one. Okay, again we have to consider that normal curve. And we need to plot where is going to be positive value and where is going to be negative value. Again consider one more normal curve. Z is equals to 0 and it is going to be positive on right hand side, is going to be negative on left hand side. As we have mentioned that third case going to be Z1 going to be greater than 0. So continue it here, that is going to be here Z1 and here going to be considered as Z2. So we need to find that area between these two, in the sense this is the area is going to be required for us and we can find the value of area of Z2 by using that table which I am going to be explained next. Next, sum of that area of Z1 plus area of Z2 is gives for us that probability of Z1 less than Z2. So these are the three cases are going to be possible if you want to find that area between two lines. One is going to be if both are positive, second one is going to be both are negative, third one is going to be one is positive, one is negative. Next, go for that next slide for how can we find the value of it. So this is going to be one more case if you want to evaluate probability if Z value going to be less than Z1. This is that, again consider normal curve right here and Z is equals to 0. So we need to find that probability of Z less than Z1. It means that and the value of Z1 going to be what? Less than 0. So that going to be placed on left hand side. We need to find the value of this area. It is our required probability value. So we already know that the value of is going to be 0.5. Why? Because we already given that it's going to be symmetric. Total area going to be 1. So half of going to be 0.5, 0.5. But I require the value of this one only. But totally. But we are able to find the value of it by using that table, that is going to be 0.5 minus the value from here given for area of Z1. Like we have to. Next, coming to the second one is case 2. Okay, if that Z1 going to be positive, means place it here. More than this, less than sense, this entire area we need to evaluate. We already given that half of this going to be 0.5 and this can be evaluated from using the table. So by adding these two means 0.5 plus area of Z1 gives our required value for us. Next, go for that One more case also is there. Where we get the value like here. So consider the normal curve here. So we need to find the value of probability of z greater than z1 whenever z1 value going to be less than 0. This is going to be z is equals to 0. So z1 value going to be less than 0 in the sense lies on left hand side. We need to find the probability of z greater than z1 means this entire value I need to evaluate. That is required a probability value for us. It can be evaluated by, so this is entirely off of the pot, nothing but is nothing 0.5 plus the value is given from us the area of z1. Coming to second case, it here same that z is equals to 0. The value of z1 is greater than 1 means it lies in the positive right side only, and I required its greater than value. This is the entire value I need to evaluate. So as I told you, this is entirely going to be 0.5, and this value we have given that area of z1. So we can find its value. It is equals to, so 0.5 going to be entire value minus, if you subtract that area of z1, we get that value of required probability for us. Next, go for next slide. This is a table. Previously I told you that what is the value of area 1 z1, area of z2, area of z3 as given to you now. So how can, if z value is going to be, suppose 1 point is given, suppose as you told, the area of z1 you want to evaluate when area of z1 value given like 2.2. How can we find area of 2.2 value at here? So look at here, here z value we have, and coming to the 2.2 at where it is, 2.2 is at here, and 2.20 is at here, we can find its value as that 0.9861. Next, coming to that one more value, I'll explain to you that if you want to find the value of okay, next I would like to find that area of z1, that is I like to consider area of okay 1.67 I need to evaluate. So how much is given from the table? 1.6 it is going to be here, and 7 in the sense the second here we are going to be get, this is the value, means consider from here and 1.6 in the sense from this is the row, this is the column. So this is going to be point for us, we need to get we are going to get 0.9525. Is that true? Like in solving the problems, whenever if you want to find any kind of values, wherever area of z that's required a probability for us, area of we can similarly find 1.43, 1.45 and 2 point, and there is a doubt, I think if in case we have the value like a of okay area of minus 1.5 is there. How can you find, as they given the previous the basic concept of finding area in between or greater than or less than values, we get that z value going to be negative. But as I told you that the characteristics of normal curve is symmetric in the sense that is going to be area is going to be always positive only. So we can get that it is nothing but area of 1 pi. It means that area of minus z value is nothing but area of z only. So it's nothing but we have that 1.5 area 1 point nothing but here okay 1.5 in the sense again it here, that is 0.9132 is our required. It can be noticed as that probability of it always represent from, always calculated from 0 less than z less than 1.5 or minus 1.5. So the value whatever we are going to be selecting from here is going to be from 0 to, start from 0 to either right hand side or 0 to left hand side, whatever the value for it. So let's go for some examples to find it. So with the examples we can get more clarity, but which I explained the previously, the concept we need to understand. By applying the concepts only we get that values are required area, that is nothing but probability of it. Now let's see that example for this one, finding areas under the normal curves. Example I given here, Okay, find the area to the right of this value. So right of this value is nothing but, so let's go for this one. I like to draw that normal curve at here. This is a normal curve. So as I explained, it's a bell shape only. Z is equals to 0. Next, Z is equals to what? 1.25 value, and should be right off. Right off in the sense we need to evaluate probability of, okay, Z is equals to 1.25, and it's greater than value only. Means greater than of Z is equals to 1.25 we need to evaluate. So this I told you that's going to be 1, is going to be 2, is going to be middle of this going to be 1.25. Z is equals to, okay now. So right of its value nothing but this area I need to evaluate. So how can you, as I given the previously, okay, this is nothing but this entirely from here going to be what, 0.5 minus probability of 0 less than Z less than, okay, 1.25. That is nothing but 0.5 minus, it can be noted as that area of 1.25. Sir, how can we find area of 1.25? Previously I given to you that one slide, that is how to find that value of it. What is the value of it? We need to find area of 1.25. Area of 1.25 is nothing but area 1 at here, 1.25, 1.28 here, 0.5 in the sense, go for this row, 1.25 is going to be here for us. So the value is nothing but 0.898944. So let's go for this one. 0.5 minus 0.8944. Sorry. 0.8944. So if you simplify, we get the value, that is our required value of when our probability value is going to be, okay, that's the right side of that 1.25. This is one example. Let's see one more example, that that is the right of minus 0.34. Let's see how can we find it for it. Again we need to go for that graph of the normal curve, and we should plot that point where Z is equals to minus 0.35. Let's see this one. Now again go for normal curve and find the value. Okay, Z is equals to 0. So we have that Z value is going to be less than 0. It should be less on left hand side. We can go for it. Minus 0.34 is that Z value. Here we need to find that value of probability of right off in the sense that greater than value of Z. It is nothing but okay, probability of so more than value of 0 minus 0.4 at here. So it means that this is the entire value I need to evaluate. I already know this is going to be symmetric. From here to here going to be what, 0.5, and this value we are able to obtain from that table. Okay, let's see this one, right? That area of minus 0.34 plus, okay, this is already we know that half of nothing but area of 0. Then how can we find that area of minus 0.35? As I given the table, as I given in the table, here I have the values of only positives only, but I already told you that that is area of minus Z is nothing but area of Z. Why? Because it's going to be symmetric. So we can write here. So we can write next step that area of 0.34 plus 0.5. So now you may, okay, calculate the value by using the table. So we have the value 0.34, 0.38 here. So 0.38 here and 0.34 in the sense this is the value we need to 0.6631. So we are going to be get here. Okay, this is the next we can write for this here 0.63634 plus 0.5. This is the total sum required that probability of under So less than value and greater than value. This is the basic examples we have. So like in a similar way, we can find the probabilities in between values and greater than value, less than value, the positive or negative. And one more thing, that in statistically, if you want to find probability of any kind of real life, so by using normal curve, it's going to be easy to find that value of it. Okay, that's it. My lecture on the normal distribution. So thank you to all.